Section 1. The ordinary object that breaks science there is a coffee cup sitting on a table. It's ordinary ceramic, warm. Maybe there's steam rising from the surface. It doesn't look like a threat to physics. It doesn't look like the kind of object that could destroy one of humanity's most seductive dreams. But it does. Time travel has always lived in the realm of imagination. Machines, wormholes, paradoxes, heroes, rewriting history. Yet in serious physics, the idea isn't automatically dismissed. Einstein's equations allow strange geometries. Closed time-like curves appear in certain solutions. On paper, the universe does not strictly forbid the possibility of moving backward along a timeline. And that's where the coffee cup becomes dangerous. Because if backward time travel were truly possible in our universe, not just mathematically, but physically, then this cup should be capable of something extraordinary. If time can reverse, then shattered pieces should sometimes leap from the floor and reconstruct themselves. Spilled coffee should occasionally gather from the table and rise back into the cup, but it never does. Not once in the history of observation has a broken cup spontaneously reassembled. The laws governing microscopic particles are largely reversible. A collision between atoms can unfold backward just as convincingly as forward. The equations don't scream when reversed. They remain calm, indifferent. It screams irreversibility. The coffee cools. It never spontaneously heats itself from room temperature. The ceramic cracks. It does not heal. Something about reality insists on direction. That insistence is quiet but absolute, and it hides inside the most ordinary objects. The coffee cup does not know about wormholes. It does not care about science fiction. It simply obeys the statistical rules of the universe. And those rules lean relentlessly toward disorder. If time travel to the past were truly accessible, then entropy, the universe's measure of disorder, would sometimes run backward in plain sight. The coffee cup sits there obeying a deeper law than imagination, and in its silence it exposes a truth. Time may not be something we can reverse, because the universe itself resists it at every level. Section 2. The arrow hidden inside chaos if the coffee cup is the witness. Entropy is the culprit. Entropy is not destruction. It is not decay in the dramatic sense. It is simply probability. It is the quiet mathematics of how arrangements of particles prefer to exist. And what those particles prefer is disorder. Imagine the coffee cup again. Inside it, trillions upon trillions of molecules are moving, colliding, vibrating. When the coffee is hot, those molecules are moving rapidly. The surrounding air molecules move more slowly. When the cup cools, energy spreads outward. The fast molecules transfer motion to the slower ones. Nothing mysterious happens. Energy disperses because there are vastly more ways for it to be spread out than concentrated. That is the arrow of time. The microscopic laws don't demand direction. If you recorded molecules bouncing and played the footage backward, the motion would still obey physics. On that level, forward and backward are equally acceptable. But scale changes everything. When you zoom out to the level of cups, tables, air, and rooms, probability dominates. There are countless ways for a cup to be shattered, but almost no ways for shards to spontaneously reassemble. There are endless configurations of lukewarm coffee molecules dispersed into the air, but only one narrow configuration that keeps them hot inside the cup. So the universe slides toward what is statistically easier. Disorder is not forced, it is overwhelmingly favored. And here is the devastating implication for time travel. Traveling backward would require entropy to decrease. It would require the universe to move from probable states to astronomically improbable ones, not just locally but consistently. The shattered cup would have to reassemble. The cooled coffee would have to heat up without an energy source. Every molecule would need to retrace its steps with impossible precision, not once, but across the entire environment, because entropy is not a suggestion. It is a statistical avalanche. Time feels directional because entropy increases. That increase gives us memory of the past and ignorance of the future. We remember lower entropy states behind us. We never remember higher entropy states ahead. So the arrow of time is not written into equations as a command. It emerges from overwhelming probability, and that probability does not favor miracles. The coffee cup doesn't forbid time travel philosophically. It forbids it statistically. And statistics in a universe this large might be stronger than destiny. Section 3, Einstein opened the door. Here is where things become unsettling, because if entropy seems to slam the door on time travel, physics itself quietly unlocks it again. In 1915, Albert Einstein published the field equations of general relativity. These equations do not describe gravity as a force. They describe gravity as geometry, the curvature of space-time caused by mass and energy. Space and time are woven together into a single fabric, flexible and dynamic. And when mathematicians began exploring those equations, something extraordinary appeared. Certain solutions allow space-time to curve back onto itself. In 1949, Gödel discovered a rotating universe solution in which time loops were possible, paths through space-time that return to their own past. Later, physicists like Frank Tipler proposed that an infinitely long, rapidly spinning cylinder could twist space-time enough to permit similar loops. These are called closed timelike curves. On paper, they are perfectly valid solutions to Einstein's equations. That means something profound. The fundamental geometry of space-time does not automatically prohibit backward travel. The equations themselves remain indifferent to paradox. They allow the mathematics of returning to yesterday, so the universe at its deepest geometric level does not scream. It whispers perhaps, and that whisper is powerful because it tells us that time's arrow is not built into space-time structure in the same way distance is. You cannot move north and accidentally arrive south. But under certain extreme conditions, you could, mathematically, move forward and arrive behind. Yet there is a catch. All known solutions that permit time loops require conditions so extreme they border on the unphysical, infinite cylinders, exotic matter with negative energy density, cosmic scale rotation that we do not observe. Einstein's equations are permissive. Reality may not be. So now we face a contradiction. Thermodynamics tells us backward motion would demand impossible decreases in entropy. Geometry tells us space-time could, under exotic circumstances, allow it. The coffee cup says no. Einstein's equations say maybe. And between those two answers lies one of the deepest tensions in modern physics. Section 4, the universe protects itself. If geometry allows time loops and entropy resist them, then something must decide which side wins. That something might be the universe itself. In the late 20th century, Stephen Hawking proposed what he called the chronology protection conjecture. The name sounds almost poetic, but the idea is ruthless. The laws of physics may conspire to prevent time travel before paradoxes can form. In simple terms, the universe might censor its own loopholes. The reasoning is subtle. When physicists examine models that allow closed time-like curves, especially wormholes, they find something troubling. As soon as a time loop begins to form, quantum fields near that region appear to fluctuate violently. Energy densities spike, radiation intensifies without limit. The mathematics suggests that the very act of trying to create a time machine would generate infinite instability, and infinity in physics is usually a warning sign. It often means the theory is being pushed beyond what reality permits. So imagine trying to bend space-time into a loop. As you twist it tighter, quantum effects grow stronger. Particles pop in and out of existence. Vacuum fluctuations amplify. Energy piles up catastrophically before the loop completes. The structure destabilizes. The universe doesn't need to forbid time travel directly. It only needs to ensure that any attempt collapses under its own physics. This idea doesn't rely on morality or cosmic fairness. It doesn't care about paradoxes like killing your grandfather. It simply says that self-consistency may be enforced by instability. The deeper implication is striking. Perhaps time travel is mathematically allowed, but physically unattainable. The equations open the door, but quantum reality slams it shut. The coffee cup cools, entropy rises, and any effort to reverse that grand direction triggers resistance at the smallest scales, not through conscious design, not through intention, but through the raw structure of physical law. If Hawking was right, the universe doesn't just drift toward disorder, it actively guards its timeline. And every ordinary object, every cooling cup, every aging star, participates in that quiet enforcement. Section 5, the illusion we cannot escape. So where does that leave us? Between permission and prohibition. Geometry allows the fantasy, thermodynamics resists it. Quantum instability threatens to destroy it. And the coffee cup, humble, silent, continues cooling as if the debate never existed, which raises a more unsettling possibility. What if time travel fails not because we lack technology, but because our intuition about time is flawed? We experience time as flow. We imagine ourselves drifting along it, perhaps one day learning how to paddle upstream. But physics increasingly suggests that this sensation of flow may not be fundamental at all. In many modern interpretations of space-time, past, present, and future coexist within a four-dimensional structure. Events are laid out like coordinates on a map. Nothing is moving through time any more than Paris moves toward Rome on a globe. The movement may be in us. Our consciousness might be what traces a path through a static structure, generating the feeling of progression. Memory records lower entropy configurations. Anticipation points toward higher entropy ones. The asymmetry of entropy becomes the asymmetry of experience. Time feels directional because we are built inside its gradient, and that changes the question entirely. Perhaps traveling backward is not like turning around on a road. Perhaps it is like trying to unburn paper, not forbidden by geometry, but forbidden by overwhelming probability and structural stability. The universe doesn't know what before and after mean in the way we do. It only knows configurations. It only knows equations. The coffee cup cools because dispersed energy is statistically favored. We age because biological systems accumulate entropy. Stars burn because nuclear fuel moves toward equilibrium. No cosmic clock ticks, no master timeline advances. There is only change, structured, probabilistic, irreversible at scale. So the coffee cup doesn't just kill time travel, it exposes something deeper. Time, as we imagine it flowing, reversible, navigable, may never have existed in the first place.